In this video, we'll be focusing on the most important features and functions of the software and how they interact with each other. The EDSP31-68 is a powerful digital signal processor that is designed to provide you with complete precise control over the audio signals in your vehicle's stereo system. So whether you're a paid installer or a casual music enthusiast, installing at home, new to DSPs, this guide will provide you with a basic understanding to get the most out of your EDSP31-68. We'll start this tutorial in sequential order, describing each section of the EDSP31-68, including its settings and options available along with their functions. More detailed information can be found in the Unit Owner's Manual. Once your audio components are installed and wired up in your vehicle, including the source unit, speakers, EDSP31-68, and amplifiers, it's time to configure the EDSP31-68 for optimal system control. To start, download the compatible software for the EDSP31-68 to your Windows 8 through 10 laptop. Visit the product page to find the PC download. To begin, click on the red PC software download button to download the software to your PC. Once the download is complete, locate the software file in your PC's downloads folder. Unzip the folder and locate the application file named EDSP31-68.exe. If you encounter a Windows pop-up, simply click on More Info and then proceed to select Run Anyway. Once the installation is complete, you'll find the EDSP31-68 icon, which you can save as a shortcut on your desktop. Double-clicking the icon will open up the main EDSP31-68 user interface. Now that we have the UI open, we'll need to set up the most basic settings on the EDSP31-68 so that we can then make the proper adjustments to suit the system setup. Firstly, let's talk about input signal selection. This is where you choose which input source you want to use. High-level input allows using the factory speaker outputs as the input source. You can choose to use only front speakers or add the rear for front and rear fading. You can also sum the input channels for multiple speaker systems with separate amplification for tweeters, mid-ranges, and subwoofers to ensure a complete full-range input. Bluetooth. The EDSP31-68 allows you to use an optional Bluetooth dongle to stream music directly from your smartphone to the DSP without the need for an additional source unit. The Bluetooth dongle can be purchased separately as model number EDP31-BTD. RCA. This input is for aftermarket head units for audio inputs, some of which feature front, rear, and subwoofer RCA outputs. The EDSP31-68 only requires a single set of RCA inputs to feed all 8 output channels. You can set up the input to output relation in the DSP's mixer section, which we'll be discussing next. After setting up the audio input, you must set up the mixer section of the EDSP31-68 to be able to assign the relation between the inputs and the outputs. We'll use RCA audio inputs as our input for this tutorial. The EDSP31-68 features up to 6 input channels. The mixer section will automatically default to your predetermined audio input. On the left side of the UI, you'll see input signal with each of the RCA inputs. You'll then see that the output channels are all listed at the bottom of the UI. Each output channel requires a link to an input channel to work properly. Make sure to note down what left and right audio input signals you're using so that you will always remain at correct left and right balance throughout your setup. We'll list the basic setup for the 2, 4, and 6 RCA inputs. Using front RCA inputs only, RCA1 and RCA2. Using front and rear RCA inputs, RCA1, 2, 3, 4. Using front, rear, and subwoofer RCA inputs, RCA1, 2, 3, 4, 5, 6. After setting up the input-output mixer, You will then need to set up the crossover section of the EDSP31-68 to ensure that your speakers will be reproducing the optimal audio signal for your system setup. The crossover setup is normally done in paired channels. For this to take effect, you must link Output tab on the far bottom right of the UI. By selecting this, any audio adjustments made on the DSP will automatically be shared with its paired channel. For example, adjusting channel 1 will also adjust over to channel 2. Researching the audio capabilities of each speaker in your setup is important to avoid exceeding their performance characteristics. Once you know the required settings for each channel, you can adjust them in real time in the crossover section. While textbook settings can provide a good starting point, fine-tuning the crossover points to your personal preferences is the best way to achieve optimal performance. In the following sections, we will explore each aspect of the crossover. Crossover type determines the slope of the crossover filter and the way in which the low and high frequency signals are separated. The EDSP31-68 offers 3 types of crossover filters: Linkwitz-Riley, Bessel, Butterworth. Linkwitz-Riley. These filters have a flat frequency response and a steep roll-off with a slope of 24 decibels per octave. This results in a 24 dB decrease in signal level for every octave above the crossover frequency. Bessel. These filters have a 12 dB per octave slope, resulting in a gentle roll-off and a linear phase response. The signal level decreases by 12 dB for every octave above the crossover frequency. Butterworth. This filter has a slope of 12 dB per octave for each filter order, meaning the roll-off increases with each additional filter order. The choice of crossover type and point depends on the system, speaker size, type of speaker, and the desired sound quality. In the Xover section, there are HPF, high-pass filters, and LPF, low-pass filters. LPF is a filter that only passes signals below its cutoff frequency, while attenuating all signals above it. HPF is a filter that only passes signals above its cutoff frequency, while attenuating all signals below it. Some example starter crossover points below. Tweeters, 3800 Hz high pass. Mid-ranges, 80 Hz high pass, 2800 Hz low pass. This creates a bandpass filter. 6.5-inch two-way coaxial, 90 Hz high pass. Subwoofer, 80 Hz low pass. These filter settings are meant as starting points, and fine-tuning will be necessary to achieve optimal reliability and performance. The octave section, which is also referred to as slope, enables you to choose the decibel per octave slope setting that you prefer. You can make adjustments to the slope by selecting one of the available options from the drop-down menu. The selectable octave settings include 6 dB, 12 dB, 18 dB, 24 dB, 30 dB, 36 dB, 42 dB, 48 decibels per octave. The slope setting is significant in several ways. Here are a few examples. A two-way coaxial speaker should have an HPF slope set around 12 dB to blend with the subwoofer and protect it from damaging low bass frequencies. If you're using a subwoofer, you may want to consider setting the LPF slope to an 18 or 24 dB per octave. This can help prevent localization of the subwoofer within the vehicle and provide a sharper cutoff for better performance. If you plan to use pro audio style speakers with limited frequency bandwidth and higher power, it is suggested to use a higher slope to avoid playing anything outside their designed range. A slope between 24 to 48 dB is recommended. The slope is even more crucial for smaller speakers in protecting them. Output gain control. This control allows you to adjust the level of the output signal for each individual channel or link channels at the same time. You can increase or decrease the level using the slider to match the output levels of the other channels. or to achieve the desired sound. Phase Align. This function helps to correct phase issues in the audio signal. When enabled, it shifts the phase of the audio signal to align it with the phase of the other channels. This helps to ensure the audio signal is in phase and sounds coherent. Mute. The mute function lets you turn off the audio signal for a channel, which can be useful for temporarily silencing or soloing a specific channel to evaluate the sound. Delay. The delay function allows you to adjust the delay time for each channel. This can be useful when you have speakers at different distances from the listener. The equalizer section allows the user to adjust the frequency response of the output signal. dB, which stands for decibels, indicates the amount of cut or boost that is applied to the selected frequency range. Positive values correspond to boost, while negative values correspond to cut. This can be modified by either dragging the sliders or clicking on any of the 31 frequency bands and adjusting them up or down. Q refers to the bandwidth of the selected frequency range, which determines how narrow or wide the boost or cut will be. A narrower Q value results in a more focused boost or cut, while a wider Q value results in a broader boost or cut. You can adjust the Q value by typing a numeral value using the up or down arrow keys or dragging the black squares in the graph. The frequency parameter of the equalizer section allows the user to choose and adjust the center frequency of the selected frequency range. This can be done by typing a numerical value or dragging the desired band horizontally. While adjustments can be made by a trained ear with knowledge of acoustical frequencies and speaker position phasing, it is recommended to use a real-time analyzer, RTA, for optimal results. Using an RTA, you can see a visual representation of each frequency band and how your system is reproducing it while playing pink noise. Warning: do not press left mouse click on any preset button if you have unsaved work. This will delete any changes you've made. In the preset section, you can save, load, and delete presets. To save a preset, you need to first configure the settings to your desired values. Then hover your cursor above the desired preset number. Right-click on the preset button, and it will open a window in which it will ask Load DSP Setting, Save as DSP Setting, Delete DSP Setting. To load a saved preset, click on the Preset button again to open the preset window. In the preset window, you can see a list of saved presets. Click on the preset you want to load and then click on the Load button to apply those settings to your current configuration. It's important to note that when you load a preset, it will overwrite any existing settings you have. So make sure to save your current settings as a new preset if you want to keep them for later use. Click on this icon to save all system configurations to the PC hard drive or to load a saved PC customized setting from a previous tuning session. We hope that you found this tutorial informative and useful. Thank you for watching. Be sure to follow us on our social platforms.